Welcome to Honors Geometry, Lesson 4.2, 4.3, and the first part of 4.4. Section 4.2 deals with congruent figures and CPC-TC, also known as corresponding parts of congruent triangles are congruent. First of all, let's go ahead and move right on to congruent figures. If two figures are congruent, then the corresponding angles and corresponding sides are congruent. First, you have that these two pentagons are congruent. That means there are quite a few things that are going to be congruent. Corresponding angles and corresponding sides will be congruent. So we should be able to make the following congruent statements. Angle A is congruent to angle K. Angle B is congruent to angle L. Angle C will be congruent to angle M. Angle D is congruent to angle N. And angle E is congruent to angle J. And you don't even have to look at the pictures to see that. First letter, last letter, last letter. That's one way you can figure out the corresponding parts without even having a picture to look at. How about the sides? Segment AB is congruent to segment, first two letters on the other one, segment KL. And then just go around the pentagon. Segment BC is congruent to segment LM. Segment CD is congruent to segment MN. Segment DE, yes, that's going to be congruent to segment NJ. And the last two letters, segment EA or AE, either way, congruent to segment JK. And those will be the congruent statements that we can be able to say just by having been told that the pentagons are congruent. Alright, let's laser focus in on triangles since this chapter is about triangles. Alright, you're given that triangle ABC is congruent to triangle XYZ. Name 6 congruencies. And we're going to name those 6 congruencies because of CPC-TC, which again is corresponding parts of congruent triangles are congruent. So, 6 congruencies, 3 angles, 3 sides. Angle A, congruent to angle X. Angle B, congruent to angle Y, I don't know. And angle C, congruent to angle Z. And then the sides, AB is congruent to segment XY. Segment BC is congruent to segment YZ. And segment CA is congruent to segment ZX. That plain, that simple. What about if you're not given a picture? Okay, you're given that the triangle EFG is similar to triangle KLM. You don't even need to look at a picture to give me the 6 congruencies. First one is angle E is congruent to angle, that's right, K. Angle F is congruent to angle L. And angle G is congruent to angle M. And the congruent sides, segment EF is congruent to segment KL. Segment FG is congruent to segment LM. And segment GE is congruent to segment MK. It's really that simple. And that's all there is for section 4.2. We will now, since it is such a small section, we will move on to section 4.3 and 4.4, the first part. Okay, section 4.3 and 4.4a are ways to prove that triangles are congruent. The normal definition of congruent triangles is that if all the corresponding parts are congruent, the three congruent angles of one triangle congruent to three angles of another triangle, and the corresponding sides of one triangle congruent to the corresponding sides of the other triangle, then the triangles are congruent. Now we're going to come up with three parts that will make it such that the triangles are congruent to each other. So let's go ahead and move on. Alright, the first way to prove triangles are congruent is the side-side-side postulate. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. AB is congruent to DE because they both have one tick mark. BC is congruent to EF, they both have two tick marks. And AC is congruent to DF because they have three tick marks. So that means that the three sides of one congruent to three sides of another. Then you can say that triangle ABC is congruent to triangle DEF. Alright, let's go ahead and move on. The second way that we can get triangles congruent to each other is the side angle side postulate. It says in words, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Please let your eyes focus in on the name side, angle, side. Notice that the angle is between the two sides. Notice on here that this angle is included in, it is between the two sides. This triangle over here, this angle is included, it's in between the two sides. So usually when we make a congruent statement, at least what I like to do is to put the first triangle in alphabetical order. JKL is congruent to, now let's do the corresponding parts of the other triangle. J corresponds with S, K corresponds with T, and L will correspond with R. And if you cannot see that correspondence, what you need to do, is not pick up that S. And never mind, I'm not being able to do that right now. So let's go ahead and move on. Now you know what? I'm going to show you how to do this. If you can just, oh wow, there's something there in there. There we are. JKL congruent to STR using the side angle side postulate. Okay, what I was trying to do was to grab all those there, and then if you rotate it around in your brain, if you can't do it manually, is to turn that triangle around so you can see the corresponding parts in the right place so that they actually look like they're corresponding. Alright, let's go ahead and move on. Alright, we're going to investigate which method gets the triangles congruent. And then what is the congruence? They're asking you to write a congruence statement. Alright, so let's look at the first one. Okay. I see three sides of one triangle congruent to three sides of another triangle. So I think that those triangles are congruent using side, side, side. And so triangle ABC is congruent to triangle. Okay, what corresponds with the A? That would be the F. What corresponds with B? The E. And what corresponds with the C? The only one left is D. Okay, how did I do that? I saw that A right here was between the 1 tick mark side and the 3 tick mark side. So over here I came over to the 1 tick mark side and the 3 tick mark side. That was F. Then I looked at B, which is between the 1 tick and the 2 tick. So over here, between the 1 tick and the 2 tick, that's angle E. And that's how I got the order. And that would be using side, side, side postulate. Alrighty. Next, please. Alright. Looking at this, notice that the included angle of one and the included angle of another between a set of 2 tick and 1 tick marks for both of them. Triangle. Get these first ones in alphabetical order. GHJ. Congruent to triangle. What corresponds with a G? That's right, K. Corresponds with the H, the L, and that leaves angle M to be the last letter, and this would be using side, angle side postulate. Now sometimes they may not give you enough information, and you have to use your vast knowledge of everything you know so far. And I think the first thing that you'd like to say is that segment NO is congruent to segment NO using the reflexive property. So we'll 3 tick mark that all by itself, and once we do that, it's fairly easy to see that the triangles are congruent using side angle side. So first triangle, triangle NOP, usually try to get that first one in alphabetical order. Triangle. What corresponds with the N? N. Corresponds with the O? O. And NOQ. And this again, which method? 3 sides of one, 3 sides of the other. Side, side, side. Postulate. Sometimes we want to, wow, what just happened there? I don't know. That was not cool, whatever happened. Sometimes we're going to have to look again at the triangles and see if there's any other information we can find out. And I think the first thing that we would like to say is that angle RVU is congruent to angle S. Nope, that would actually be TVS using the vertical angle theorem. Vertical angles are congruent. That angle right there is congruent to that angle right here. There. Notice that those sides surround the angle, so that is going to be using side angle side postulate. That is how we get triangles congruent. Let's quickly move on, seeing how we've got about 45 seconds. Alright, what extra piece of information is needed to prove that triangles are congruent using side, side, side? Well, I see that I've got 2 sides of one congruent 2 sides of another. Using side, 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 I think we need to see that AC is congruent to segment ZN. How about side angle side? We need to get those included angles between the sides congruent, so angle B needs to be congruent to angle M. And just like that, this will end Honors Geometry Lesson 4.2, 4.3, and 4.4a. Good night.